These are properties of half angles. So we already know double angles, right? Or composite argument properties, or our double angle properties formulas here. These are all the formulas that we've done already for double angles. We're gonna focus on primarily on these two here because we're gonna do a hack. And I want you guys to just recognize. So let me go ahead and write the first one here because, Chav, why are you only looking at those two? Because notice that's cosine 2a and I have a cosine squared. And notice that's also cosine 2a and I have a sine squared. Okay, so what about that, Chav? All right. Notice, so let me go ahead and start by writing this. Cosine 2a equals 2 cosine squared of a minus 1. Observe that this angle here is half of this angle here. Come on, Lopez, focus, miss. So we can make sure that we got this. So notice, do you guys agree that this angle A is half of 2A? Okay, so then that means I can rewrite this like so. I can say cosine of A equals 2 cosine squared half A. And I know that I didn't put a parenthesis on the first one. It doesn't really matter. But notice that the argument is right there. And this is still equivalent. Chop, why is it still equivalent? Because this angle is still half of the 1.5 on the outside. Does that make sense? So in case you're saying it doesn't, because I saw someone say no. Okay. Well, hopefully you will focus, but let's check it out. I'm going to make up a number like A. I'm going to say A is 50 on the top line. If A is 50, what's double of 50? So I have cosine of 100 equals 2 cosine squared of 50 minus 1. Okay, let's see if it still works. Now I'm going to change the A, but I want to make sure it's the same. Now my A is 100. Cosine 100, and then what's half of 100? 50. And look, cosine 100 equals 2 cosine squared 50 minus 1. Do I have the same statement? Yeah. See, so it works. It's still, I know, you're like, I know. Some of you are like, Chop, but that's still A. Maybe I should use a different letter like B. So to signify it's a different angle. When I'm talking, this A is not this A. It's a hack. So let me write the word hack there.
Can I have a paper cup?
Oh, I didn't give you one? Well, I'm sorry, miss. Oh, too bad. I'm not going to give you one. Miss, that was a joke. LOL. LMFAO. Oh, that's a band. No, that's a band. That's a band. That's a band from 2010. You guys were like a year old when the shuffle song came on. 2 years old? Okay. All right. Did that make sense? L squared? Okay. So there it is, guys. So what am I going to do? Well, this is called half angles. So that means I probably want a formula in terms of my half angle. Do you know what I mean, guys? So I'm going to rewrite this. I'm going to put this on the left-hand side because I like to solve on the left. 2 cosine squared half A minus 1 equals cosine A. I'm going to put a side note somewhere. Remember that cosine squared of half A really means cosine of half A, and then giant parenthesis with a square on the outside. I want to make sure that we remember that. My first move, I'm going to move this minus 1 to the right. Instead of writing it plus 1, cosine A plus 1, we're going to put it in the front. Chop, why? I wanted to mimic the table that I gave you guys in a little bit. 1 plus cosine A. And now I want to get rid of the 2 in front of the cosine squared. So what do I got to do? Yeah, divide everything by. So then I'm going to have cosine squared half A equals 1/2. And instead of writing cosine A plus over 2, I'm going to write the 1/2 in the front like that. 1/2 cosine A. It's the same. It's the same. And then how do I get rid of that square there in front of the cosine? Cosine squared. Square root both sides. So now I'm going to have cosine of half A equals plus minus square root. Why is the plus minus there? Well, it's the same deal with square root of 9 as plus minus 3. And then depending on where our angle is and what quadrant half A is, that's what we'll decide whether it's a positive or a negative. Okay. If you Google it, maybe you'll find the formula written this way. Sometimes they factor out the half, so I'm going to go ahead and do that because Mr. Paul Forrester, that textbook that we supposedly use, writes his formulas like this. Hello, Mr. Forrester, if you're looking at my video. I doubt it, but just in case. I hope you're proud of us, sir. Okay. So there it is. Sometimes different textbooks write it a little different. They go ahead and factor that 1/2 or take that out. So you'll see like a square root of 2/2. It just depends what website you hit up, what textbook you see, all that good stuff. Cool or not cool? All right, so there it is. So put that one in a rectangle. That is my half angle formula for cosine half A. Child, why do they call it half angle formula? Because it says half A, half of angle A. I'm doing the same thing with this one right here for sine half. I'm going to rewrite it. So I'm going to write cosine 2A equals 1 minus 2 sine squared A. And then I'm going to do my hack. And I'm going to write cosine A equals 1 minus 2 sine squared of half A. I'm going to write this on the left-hand side. 1 minus 2 sine squared of half A equals cosine A. Am I going okay, guys? I'll slow down. I'm trying to solve for sine of half A, so I need to move the 1 on the left-hand side to the right. When I move this 1 to the right, it turns negative. So negative 2 sine squared of half A equals negative 1 plus cosine A. Now I need to get rid of that negative 2 in the front. So I'm going to divide every single term by negative 2. Negative divided by negative is A. So I'm going to write sine squared of half A equals positive half, because negative divided by negative, minus 1/2 cosine A, because that's positive divided by negative. Still okay? We're really close. How do I get rid of that square? So now I have sine squared. You said square root, so it goes away. Sine half A equals plus minus square root 1/2 minus 1/2 cosine A. And then the last I'll wait. I'm going to factor out a half A on the right-hand side. So sine half A equals plus minus square root. Here's my 1/2 factored out. 1 minus cosine A. And there it is. Half angle property for sine half A. Are we okay so far, guys? Okay. All right. I'm going to go ahead and derive the tan one, guys. For the morning or 7th period, I didn't derive it. I just told them to use it. Yesterday, I did derive it for both classes. I know that the formula is here. I'm just going to derive one of these. It does not matter which one. And the only purposes of doing this is because I want to show you that it comes from somewhere. Does that make sense, guys? These formulas just don't magically appear. So I'm going to write tan. I'm going to take a different color, and I'm going to write tan half A. And my hack is going to be that tan is sine over cosine. So I'm going to write sine of half A over cosine of half A. And well, I have my sine of half A right here. And I have my cosine of half A right here. So I can write plus minus square root 1/2 parentheses 1 minus cosine A over plus minus square root 1/2 1 plus cosine A. Law of exponents. I see a square root on the top. I see a square root on the bottom. I can do one giant square root. Plus minus big square root 1/2 parentheses 1 minus cosine A over 1/2 parentheses 1 plus cosine A. What's going to cancel? No, not the cos. The halves. Bam, bam, get them out of there. So now I have square root of 1 minus cosine A over 1 plus cosine A. Now what, Chav? We're stuck. There's still a plus minus on the outside. All right, we can multiply this by the conjugate of whatever you want, either the numerator or the denominator, and we'll get one or the other. Let's go ahead and multiply this sucker by 1 plus cosine A over 1 plus cosine A. This is still under the radical here. So this is just like multiplying by 1, so you don't change anything. Chubb, I don't understand why you're doing that. We wanna like take something out of that square root. And we do that. See, the top is the difference of squares. So here's what you're gonna get. You're gonna get plus minus big square root. You're gonna get 1 minus cosine squared A over, and then the bottom we have 1 plus cosine A times 1 plus cosine A. So you're gonna keep that binomial. Binomial is just a fancy word for two terms there. 1 plus cosine A, put that in parentheses, and put a square on the outside of that. Then side note, you guys know that cosine squared A plus sine squared A equals 1. And notice that I have 1 minus cosine squared there. So if I move the cosine squared to the other side, that just becomes sine squared A equals 1 minus cosine squared A. That's just a side note. So I'm going to replace that with sine squared. Sine squared of A. So here's what I now have. I have plus minus square root sine squared A over 1 plus cosine A, close it square. We're still okay? Okay. This becomes this square root of sine squared A over square root of 1 plus cosine A squared. And then the square and square roots just cancel out. Do you guys see that? Sine A over 1 plus cosine A. And I guess technically you still have that plus minus, but I'll leave it alone. And there it is. That was just so we can derive, guys. That's your tan half A. Do you have to memorize that? No, you can always derive it from scratch. What's up, Hernandez? Ask me. Ask me, miss. I want you to.
No, I was just trying to read something.
Oh, does my handwriting suck?
No, I don't have my glasses.
Oh. I think we're about 3 or 4 years away, guys, where, I mean, the technology is already there, where you guys will have a tablet and you can it just populates already. But we're about 4 or 5 years away from mass adoption, where you just have your tablet and be like, you know what I mean? All right, let's go to the exciting stuff, because you guys are probably like, man, that was drooling. All right, guys, so here are the properties. And I know you can tell that I took this out of a textbook here. It's coming from Paul Forrester's textbook. These are the same formulas that we just derived. Isn't that cool? Okay. How do you use them? Don't worry, we're gonna get exciting. We're gonna turn up right now. Okay, ready? Check it out. Example 1 has A, B, C. So it's these 3 for example 1. It's gonna get awesome. Look at this. If cosine A is 15 over 17 and A is in the open interval between 270 and 360, so I'm in quadrant 4, angle A is, find the exact value of cosine half A. Okay, guys. First, on the side, I'm going to say A is between 270 degrees and 360 degrees. In the past, we would write a reference triangle, but trust me, it's better if we do it like this, like that. All right, check it out. What am I going to use? Well, I have to use my half angle properties for cosine, because it says cosine of half A. So I'm going to write cosine half A equals plus minus square root 1/2, parenthesis 1 plus cosine A. Lucky for me, did they tell me what cosine A is? Yes, they told me that cosine A is 15 over 17. So that's what I'm going to use to plug in here into that cosine A. So I'm going to write plus minus square root, and I'll try to go slow, guys. 1/2 parenthesis 1 plus 15 over 17, because that's what cosine A is. Have I lost anyone? Okay, I want to add it to 1. So I'm going to turn that 17. I'm going to turn this 17. I'm going to turn that 1 into 17 over 17, because 17 over 17 is still 1. Does that make sense? So now when I add them up, plus minus square root 1/2 parenthesis 17 plus 15 is 32, and then the denominator stays at 17. I can hear the coach. Okay. Are we still okay, guys? All right. And then you do whatever you think is easiest for you, but I think this is the easiest for me. I see a 2 in the bottom. I see a 32 in the top. And since I'm multiplying here, and there's a little, see, that's in the bottom, that's on the top. I just say, how many times does 2 go into 32? That's what I do. If you don't think that's easier, you can just do 2 times 17, and then you can just reduce everything. All right, so here's what I have. You want me to close the window? Yeah, go ahead. So now I have this square root of 16 over 17. Oh, yeah, that makes a big difference. LOL.
What's going on? You're just walking around the neighborhood, I think.
I don't know. Zombies. Okay. Law of exponents, guys. Plus minus square root of 16 over square root of 17. What's the square root of 16? If I don't ask you to rationalize it, this is a perfectly acceptable answer. Do you think Delta Math will take this answer? No. They're going to want you to rationalize it. So when you rationalize it, plus minus 4 square root of 17 over 17. Just multiply the top and bottom for my YouTube fans that maybe don't know. By square root of 17 over square root of 17, that's just a 1. Anytime you multiply by 1, it's just the same number. It's the same expression. The value doesn't change. They're multiplying by 1. There it is, guys. My exact answer. Now I got to choose positive or negative. So I bet you what you're thinking, Ms. Price, is how would I choose positive or negative? Well, this is not a full angle A. This is half of A. So you're going to come up here and you're going to go like, well, all right. Well, that's A. A is between 270 and 360. So half of A, well, I guess I better take half of 360. What's half of 360? 180. What's half of 270? 135. So the angle half A is between 135 and 180. What quadrant is that? 2. And in quadrant 2, is cosine positive or negative? Negative. So circle the negative one. So my final answer, cosine of half A is nothing more than negative 4 square root of 17 over 17. What do you guys think? Not bad, right? Not bad. Okay. Okay. Are we entertained? Okay, good. All right. The next one, guys, cosine 2a. This is just like what we've done in the past. This is just a double angle, cosine 2a. Don't make life hard for yourself. It's a double angle. Choose the formula that just has cosine in it. So I'm going to go to my cosine formulas. So look, I can choose this one. But why would you choose that one? Then I have to calculate sine squared of a, or I have to calculate sine a. I could choose this one in the bottom, but why would you? Because then I have to calculate sine again. So the best one is this one right here in the middle. Do you guys see how we're doing it? I know, guys, there's so much distractions. Can you close the door, Miss Willingham? Maybe we don't hear that noise in there. So I'm going to write 2 cosine squared a minus 1. All right. I know. All right. So here we go, guys. I already know what cosine A is. Remember what this means. This means 2 parentheses cosine A, close it, squared minus 1. This is still part of the stem of problems. They told me that cosine A was 15 over 17. So I'm just going to go 2 parentheses 15 over 17, close it, put a square on it, minus 1. Yeah. Here we go. 2 parentheses 15 squared. 15 times 15, I believe that's 225. And if 15 squared is 225, then I believe 17 squared is 289. But check, because I make mistakes all the time. I think last time I said 17 squared was 269, but no, it's 289. Okay. Here we go. I'm just going to double. What are you going to double, Chav? I'm going to double the 225, guys. It's like 2 over 1, right? So 225 times 2. So let's see. 450. 450 over 289 minus 1. How am I going to subtract 1 without a calculator? All you got to do, my denominator is 289, so turn that 1 into 289 over 289. See? So this is going to be 450. I'll go ahead and write it out. Minus 289 over 289. Okay. 450 minus 289. This is how I do it. Maybe you guys are smarter than me. You can just do it immediately. But I subtract 300 and then add 11 because the difference between 289 and 300 is 11, right? So 450 minus 300 is simple. That's 150, see? And then add 11 to 150, I see 161. That's how my brain works. I do everything in pieces when applicable. If not, I'll just use a calculator. And there it is, guys. 161 over 289. That's the exact answer. Isn't that cool? Okay. And let me show. Okay, so look at letter C. So letter C is the fun part. Verify your answers numerically by calculating values of 2a and half a and find the cosines. I did this earlier, guys, and it irked me that we were off by one digit, even though it was like 12 digits long. You'll see what I'm talking about. I'll show you right now. So what they want me to do is they give me cosine A. Don't write this down. Just observe and take this in, guys. They give me cosine A is 15 over 17. I know that angle A is between 270 and 360. So let's put all our unit one, our first semester stuff together. When I get angle A by itself, when I do this, if I just do this in the calculator is stupid. The calculator is going to give me an answer in quadrant 1. So that's why we have that plus minus here in the front, remember? So I'm going to take the negative 1, and I'm going to add 360 so I can get my angle to be between 270 and 360. So check it out. And this is what I did earlier, and it irked me. You'll see what I mean right now. Watch. I'm going to do arc cosine. I'm already in degree mode. Arc cosine of 15 over 17. And I want you guys to notice that I have 28 degrees. See, that's in quadrant 1. So I turned that into a negative. So I put negative, and I scroll up, and I did this, and I go plus 360. And then initially, here's what I did. See, so that's my angle. That's between 270 and 360. Are you guys following along so far? All right, check it out. And then I did this. I went, okay, I'm going to store this as A. So now everyone knows that's A. And then I did this. I said, well, they know that cosine A is 15 over 17. So I did this. And then I went, okay, so I better get that answer if I type cosine of A of this angle. And look, I was annoyed because look at the very last digit, how it's not a 2. So why did it do that? Because I didn't put, see, this is cutting. It stops at 4, but inside the calculator, in the register, if you guys start studying computer science, that number keeps going forever and ever and ever. And so watch, I could have gotten exact, so now we're going to get the exact, if I would have done this. So I'm going to clear everything. If I would have done arc cosine, let me clear everything. Arc cosine of 15 over 17. And here's my angle. Bless you. I'm going to put negative, and I'm going to say second answer. So now it's whatever's in the register of the calculator. And then look, check it out. Plus 360. This is going to make a big difference. Well, for me at least. So now here it is. Here's the angle. Store it to A. And now watch. Look at this. 15 over 17 is this. And now I'm going to go cosine of alpha A. And let's see if it's the same. Look at that. Isn't that cool? All right, now check it out. No, check it out. Look, it's going to get better. Check it out. It's going to get better. Remember this answer that we got for cosine of half A? This one right here? We got negative 4 square root of 17 over 17. Okay, look at this. So negative 4 square root of 17. I guess I could have done negative 4 divided by square root of 17. It would have gotten it faster, but that's fine. Divided by 17. Boom. You see that number? And no, Yanni, that's a demerit. Okay, here you go. Check it out, guys. Cosine 0.5. Look, that's half of A. There it is, half of that A. Look at it. Let's see if it's digit per digit. Look at that. Cool, right? No, for real. I think that's so cool. Like, look at all these formulas, how they're just perfect. Look, my double angle, 161 over 289. Let's see what that is. 161 over 289. Push enter. And now look, cosine of 2A. Let's see. I'm not fake, guys, so we better get the same thing. Look at that. Oh, are you not entertained?
Cool.
Yeah, man.
Really cool.
Heck yeah, it's really cool. So cool. When you become an engineer, you can mess with all these signals. You can talk about the float and the binary, and then okay, I already started. I'm gonna tell you. I text Kilgore all the time when I see like nerd stuff, like the oscilloscope and the variable, and I'm gonna go ahead and show you what I'm talking about. And she never replies to it when I talk about that. So look, check it out. I sent her a screenshot of, well, groundbreaking look at the impact of, okay, well, man, where is it? Well, okay, never mind. I showed her an oscilloscope, and like, because they were dissecting a calculator. I'll show it to you guys too. You know what? I'll put it in the group me and see if you guys like it or not. It's so cool. Like, they looked at the signal analysis, like what happens when you push a button in the calculator, and you can see the signal, and you can see like what it is in hex, what it is in binary, what it is like all these different, and it's like the same stuff that you talk about, but you're seeing it in practice because they literally took a calculator and they probed it to see the signals, and they can see a digital signal on the oscilloscope. Okay, I'll stop. But it's so cool. All right, example 2. All right, guys, so we're done. So now you're just doing problems. So this one's coming from UH. This one's coming from UH. So it says, given cosine x is negative 1/7, then that x is between 180 and 270, find cosine of half x. So this is the same thing as saying this, guys. That's a half angle. It's the same. The only difference, when you do delta, it's going to be easier. I think they're all acute. So here we go. So I'm going to write cosine half x, and I'm just writing my formula for what cosine of half x is. Plus minus square root 1/2 parenthesis 1 plus cosine x. Chav, how did you memorize that? Once you do it 3 times, you pretty much kind of already got the formula memorized. For now, put it in a little note card, and you get to use your little note card for now. You won't be able to use it for the exam, but you'll be able to use it for the quizzes because we got another quiz coming up. Don't worry, I'll give you a 1 week heads up. So probably I'll tell you next time we meet. All right. Are we okay so far? All right, here we go. Look, I already got cosine x, guys. You don't have to do any more work. You're just going to go plus minus square root 1/2 parenthesis 1 plus, and cosine x is negative 1/7. So if you want to turn that plus to a minus and then not have a negative in the front, that's fine. Whatever works for you. What feels right here, guys? What should we do? What do you think we should do with that 1? What feels right? 7/7. See? You guys are nerds. So when I do the 7/7 plus minus, sorry guys, I didn't mean to offend anyone. 7 minus 1 is, so 6/7. If I have an even number in the numerator, I'm going to reduce it. Child, what do you mean? How many times does 2 go into 6? 3. So here's what I now have. I have plus minus square root of 3/7. And I know some of you can probably just do this in less steps. I'm just trying to show all the steps for everyone here, guys. So law of exponents, I can go plus minus square root of 3 over square root of 7. And then if I want to rationalize this, I'll multiply the top and bottom by square root of 7 over square root of 7. And I know some of you don't need to show that. You can just do it immediately. Plus minus 7 times 3 is 21, and then over 7. Now be careful. Some of you guys are going to look at, this one we probably would have gotten lucky. Some of you guys are going to look at the angle x is between 180 and 270, and you're like, oh, that's cosine, so it's negative. Well, you got lucky, because between 180 and 270, cosine is negative, but I'm not doing between 180 and 270. This is cosine of half x. So you need half of that. So what's half of 270? 135. What's half of 180? 90. And it just so happens that it's still negative, because in quadrant 2, cosine is negative. Does that make sense? So my answer is negative 1/7 with a square root of 21 on the side. This is how UH has it. So you can already tell what's going to be the next quiz. Cool or not cool, guys? Okay. Don't worry, we're almost done. Hold on. I know that we're pushing stamina here, guys, but we're almost done. So you'll be fine. All right. Example 3. This is from UH. Given sine x is square root of 15/4, where x is an acute angle. So if it's an acute angle, all of them are going to be positive. The output's going to be positive. Find sine x/2. Child, what do you mean by positive? You know the formula for sine half x, so that's a half angle. That's the same thing as sine half x. Has a plus minus on the outside. Square root 1/2. And instead of 1 plus cosine x, it's going to be 1 minus cosine x. And you see this plus minus? We already know it's positive because I was already in acute angle, meaning I was in quadrant 1. And if you take half of that angle, you're still in quadrant 1. So notice all the answer choices are positive, but if you had an answer choice that was negative, that's the worst answer. Delete it. Cool? Okay. So here we go. Plus minus, and I don't know why I changed it to blue. Let me go back to red. Actually, you don't need the plus minus. We already know it's positive. 1/2 parenthesis 1 minus. Oh, we don't know cosine x. Take this sine x, quadrant 1. So this is just like what we did today, right? Here's angle x. Sine is opposite over hypotenuse, square root of 15 and 4. Now slow down. Hypotenuse, I'm just doing Pythagorean theorem. 4 squared is 16. Square root of 15 squared is 15. The difference between 16 and 15 is, and the square root of 1, 1. So there we go. Cosine x is equal to adjacent over hypotenuse, so 1/4. So 1 minus 1/4. If you want, you can turn that 1 into 4/4 if you want. But if you have $1 and you take away a quarter, you just have 3/4, no? So square root 1/2 parenthesis 3/4. See? This time my numerator is odd. I can't, so 2 doesn't go into it. So I'm just going to multiply. Square root 1 times 3 is 3. 2 times 4 is 8. Law of exponents. Square root of 3 over square root of 8. So I'll slow down. I prefer to reduce the square root of 8 right here. I prefer that. But Alco says, I'm giving a shout out to Alco says, she doesn't like that. She just wants to multiply here by square root of 8 over square root of 8. That's fine. Just reduce it later on. 8 times 3, 8, 16, 24, square root of 24 over 8. Do you think Delta Math will take this answer? It won't, because you can reduce the square root of 24. Give me two numbers that multiply to give you 24. 4 and 6. Remember, this is under the radical. Which one is a perfect square root? What's the square root of 4? So this you write 2, and then what do you have left? Root 6, square root 6 over 8. And now you can reduce it. How many times does 2 go into 8? So there it is. Root 6 over 4. How do you feel? I mean, I know you feel sick a little bit, but I'm talking about like math. Okay. All right. Matthew McConaughey. I'm just doing random noises. Do you remember Mia Montemayor? You guys remember her? So, look, Mr. Monty, mayor of Monty's. I was trying to do accents one time. She was sitting in this table, and she just looks at me, and she's like, "You're just making random noises. That's not even an accent." And I felt that. I felt that right here. No, it's cool. It's cool. I laughed. She made me laugh. I'm going to forward this video to Monty Mayer. Tell her to fast forward to this spot. Okay. Here we go, guys. So it says evaluate sine of 7 pi over 8, and at first glance, all right, don't worry. We're almost done, guys. Evaluate sine of 7 pi over 8, and at first glance, you're kind of like, I don't know how to do that. I want you to recognize that 7 pi over 8 is a half angle. 7 pi over 8 is half of 7 pi over 4. Chavez, how can you tell that that's half of 7 pi over 4? Well, if I write it like this, sine parenthesis 1/2 parenthesis 7 pi over 4, close, you can see that if I take the half and I multiply 7 pi over 4, you'll get that 7 pi over 8. Do you guys see that? Okay. Cool or not cool? Does that make sense? Okay. So, by the way, or just factor out just put like factor out a 2 for that 8, and they're like, oh, 4, and then put the half on the outside, and hopefully you can see what you want. Chav, what do you want? I want that radian to be something that we know, a perfect radian on the unit circle. So either a pi over 6, pi over 4, pi over 3, or some factor of those. That makes sense, guys? All right, so here we go. I'm just using my half angle formulas. Plus minus square root 1/2 parenthesis. Let's see if you guys remember. What's the half angle formula for sine half x? 1 minus cosine x, which in this case would be perfect. See? Now you got to know, make sure that you got to use your unit circle. Here comes your unit circle. It's baby pre-cal, not extreme. Relax. Plus minus square root 1/2 parentheses. I'm going to turn, well, I guess for now we'll do it a step at a time. 1 minus, do you remember cosine of 7 pi over 4? Nope. It's right. Nope. It's over 4. All the over 4s are always going to be square root of 2 over 2. It's cosine, so it's going to be positive. Well, there's already a minus there. That minus is that minus. Does that make sense? Are we okay so far, guys? Okay. So now, let's see, plus minus. I'm going to turn that 1 into 2 over 2. See? And we're going to get, let's see, plus minus square root 1/2 parentheses 2 minus square root of 2 over 2. Let me know if something doesn't make sense. I found a common denominator. And then I put them together. We're still cool, guys? All right, what's 2 times 2? So here's what I have. Square root 2 minus square root of 2 over 4. From the 2 times 2. Law of exponents, square root in the top, square root in the bottom. You don't have to show all these steps, guys. If you can do it in less steps, go for it. I know some of you can just see it. What's the square root of 4? 2, but it's in the denominator. So if I wanted to look like my answer choices there, plus minus 1/2 square root of 2 minus square root of 2. Anything that has a plus in the inside, I'm going to delete. Delete. Doesn't look silly. Maybe. Delete. Maybe. Is it positive or is it negative? All right. No, yeah. Observe this guy right here. What do we find? Sine of 7 pi over 8. 7 pi over 8 is 1/8 pi away from pi. So what quadrant am I in? No. Pi, guys, not 2 pi. 2. I'm 1/8. I'm pi over 8 away from pi. And pi's on the x-axis, the negative x-axis, right? So I'm in quadrant 2. In quadrant 2, is sine positive or negative? Positive. Cool. Yeah. All right. I think example 5, you're going to love it because it doesn't matter how you do it. By the way, I actually remember Montalongo and her crew, Miss Garcia and Miss Cash. They came to Southside High School and we were doing this question right here. Not this exact one, but we were working on this. Yeah, try it. Okay, no problem. You're leaving De Leon, but do you feel like you have enough energy to do one more? Okay. All right. Don't worry. It'll be fast. So look, I think you're going to like this question too. All right, guys, look what it says. Example 5. Find sine of 7 pi over 12 using the sum or difference formulas. Guys, so here's what they want you to do. They want you to use either sine A plus B or they want you to use sine A minus B. Chav, which one should I use? Whichever one you want. Whatever you think is easiest for you. So what do I want? I want either A plus B to equal 7 pi over 12, or I want A minus B to equal 7 pi over 12. Chav, how do I do it? What you want to use perfect radians from the unit circle. Pi over 6, pi over 4, pi over 3, or one of those factors. Does that make sense? All right, so check it out. Give me two numbers that when I add up, gives me 7 pi, or give me 7. Two numbers add up that give me 7. Take a guess. 4 and 3. So I'm going to say this. So let's see. I'm going to write this. 4 pi over 12 plus 3 pi over 12. Does that in fact equal 7 pi over 12? Yes. And check it out. And you, by chance, you happen to use perfect. Look, 4 goes into 12 3 times. 3 goes into 12 4 times. And those are perfect gradients on the unit circle. Pi over 3 plus pi over 4. Cool or not cool? So this pi over 3 plus pi over 4 is 7 pi over 12. That is 7 pi over 12, guys. So now look, I'm going to do this. I'm going to write sine, parenthesis, pi over 3 plus pi over 4. And I'm just going to use my composite argument properties. So I'm going to write sine, pi over 3. And we just took a quiz on this. What's the next one? Cosine of, pi over what? 4. Plus cosine pi over 3, sine pi over 4. We're okay? All right, here we go. Sine of pi over 3, what is that? On the unit circle. No, the other one.
Square root of 3 over 2.
Square root of 3 over 2. Cosine pi over 4.
Square root of 2 over 2.
Yeah, those are the easy ones. The pi over 4 is cosine pi over 3. 1/2. Sine pi over 4. And look what we get. Square root of 6 over 4. Okay, you can go now, De Leon. Square root of 2 over 4. I mean, you can go whenever you want. This is America. You're free. But I just wanted I want to give you the best education, you know? I what? My mom? Yes, it's on Delta and UH. Guys, what do they do? The Delta tomorrow, the UH next week, February 5th. Guys, I want to show you. You don't have to write this down. You can just listen. That we could have done the A minus B and you still would have gotten the right answer. So think of two numbers. A number that when I subtract gives me 7. Try to make them take a guess. No, I needed to subtract. 6 minus 1 is 5. What number? 14 minus 7. Okay, let's see. Yeah, we can. Let's try 14 minus 7. So 14 pi over 12 minus 7 pi over 12. Nope, that's not going to work because we need a perfect from the unit circle. Give me another one. Guys, it's not that hard. Just give me some random numbers.
We did.
No, but it didn't work. Give me more. Try to make them both even. Both even numbers if you can. Or you know what? No. Okay, I just thought of one. 10? 10 pi minus 3 pi. And notice 10 pi minus 3 pi, that's 7 pi over 12, right? So check it out. 10 pi over 12 reduces, right? 2 goes into 10 5 times. And 3 goes into 12 4 times. So this is the same thing as 5 pi over 6 minus pi over 4. Yes or no? Now check it out. Look at this, guys. Don't worry. You don't have to write this down. I just want you guys to see it. Sine 5 pi over 6 minus pi over 4. Would I have gotten the same answer? Yes. Look. Sine 5 pi over 6 cosine pi over 4 minus cosine 5 pi over 6 sine pi over 4. Look at this, guys. Hopefully you're gonna be like, wow. Sine of 5 pi over 6. Sine is a y value. That's a positive 1/2. Cosine pi over 4. Square root of 2 over 2. That's a 2. Minus cosine of 5 pi over 6. Negative square root of 3 over 2. Negative times a negative is a positive, guys. And then sine of pi over 4. That's a 4. Square root of 2 over 2. Look at this. Look what you get. 1/2 times square root of 2 over 2. Square root of 2 over 4. Negative times a negative is a square root of 6 over 4. OMG. Square root of 2 plus square root of 6 all over 4. Just like before. Did we get the same answer? So it doesn't matter how you do it. You will get the same answer no matter what. Isn't that cool? You guys don't think that's cool? You're not entertained?
No, I just want to do that way.
Yeah, whatever. Yeah, you just need experience. That's it. That's how it is in life. When you get more experience, you become better. All right, guys. So here it is. Here's what's due. I know that it looks like the delta's not due because it says practice, the word practice. I shouldn't have put that word in there. It's due, like it's a grade. So do the delta math first so you can practice with your arithmetic. The delta math questions are easier. And then once you've practiced with the arithmetic, work on UH, trig identities 2. Notice that the due date is February 5th. So you have a week and a day, or a week and 2 days. And the attempt date by, is that tomorrow? You got attempted by tomorrow. See, so you got plenty of time. So what do you have to do? The delta? And that's a demerit. You just yawned. Sorry, miss. I'm not giving you a demerit. So a delta, that's due tomorrow, guys, and then attempt UH by tomorrow, but it's due next week. Cool or not cool? All right, we're done, guys. Good job.